Chapter 11, Part 4. We're going to move on to glial cells. So there are a couple of different types of glial cells in the peripheral nervous system, and there are other glial cells in the central nervous system. So we're going to start off with the CNS, the central nervous system. So by definition, glial cells are support cells for neurons, whether it be in the CNS or PNS. So in the CNS, the central nervous system, there are 4 types of glial cells: astrocytes, ependymal cells, microglia, and oligodendrocytes. And that one is a $5 word. If you can say that, have at it. So each of these next few slides kind of highlight the main functions of each of these types of glial cells. So astrocytes, they have processes that form feet that cover the surface of neurons and blood vessels. They regulate what substances reach the CNS from the blood-brain barrier, or through the blood-brain barrier. They produce chemicals that promote tight junctions to form that blood-brain barrier, so it's the barrier between the blood and the brain. And they also regulate extracellular brain fluid composition. The ependymal cells, these guys have cilia, or at least some of them. There's a couple different types of ependymal cells, but the ones that I usually reference are the ones that are found within the ventricles of the brain, and they have these little cilia, little finger-like projections that help to move fluid through the cavities of the brain. So ependymal cells, at least the ones that I'm referring to, line the brain ventricles and spinal cord central canal. The specialized type of ependymal cells that I'm talking about with the cilia help to form, or are part of, the choroid plexus that is found in the ventricles. And the choroid plexus, with the help of these ependymal cells, secrete CSF, which is the cerebrospinal fluid, which is the fluid found in the brain, around the brain, and through the center of this spinal cord. So these guys are important when it comes to the production of CSF, and they are closely associated with what we refer to as choroid plexus. The next glial cells that we'll talk about in the CNS are the microglia and also the oligodendrocytes. They just put these on the same slide. They are completely different cells. So the microglia are specialized macrophages, and remember that a macrophage is part of our immune cells as far as the trash trucks to clean up stuff that's not needed, or bad guys that kind of find their way in. So the microglia respond to inflammation, they phagocytize necrotic tissue or dead tissue, they eat up and phagocytize microorganisms and foreign substances. So these guys are closely associated with our immune system as far as keeping us healthy, or keeping our CNS healthy. The last the last glial cell that we'll talk about in the CNS is the oligodendrocyte, and these guys are responsible for forming myelin sheath in the central nervous system. We're going to talk about another type of cell later that forms the myelin sheath in the PNS, the peripheral nervous system, but this one is specific to the central nervous system. So a single oligodendrocyte can form myelin sheath around portions of several axons. So they are very, very able to do that. So glial cells of the PNS include Schwann cells and satellite cells. Schwann cells form the myelin sheath in the PNS. They wrap around it many times. The satellite cells surround the neuron cell bodies and provide support and nutrients. So those are the a total of 6 glial cells, 2 in the PNS and 4 in the CNS, that you should be aware of and what they do. All right, so myelinated and unmyelinated axons. So a myelinated axon is basically an axon that has an extra insulated layer, and that layer of insulation is formed by either Schwann cells or oligodendrocytes. I think that's not supposed to have an S. Maybe it is. I can't remember off the top of my head. And depends on the location. Obviously, Schwann cells are going to be found in the PNS, and the oligodendrocytes are going to be found in the CNS. So if an axon has myelination, it is referred to as white matter, and that's based on its color. But white matter is myelinated axons, so it has that extra insulated layer. And gray matter is unmyelinated. It does not have that extra insulated layer. But back to the myelination. So myelin has a couple different functions. It protects and insulates axons. It helps to speed up transmission. It electrically insulates. And it can also function in repair of axons. The myelination is not continuous. It's not one long strip. There are gaps, and those gaps are referred to as the nodes of Ranvier. And we pointed those out in the image that you're going to have to label later. Myelin sheath is fully developed around 1 year of age, and a degeneration of myelin sheath occurs in MS, multiple sclerosis, and also can happen in some cases of diabetes. So here's an image of the myelination, and I'm going to go back to the slide that we were just at, but I want to show you it's kind of like a paper towel roll, right, that wraps around it and around it and around it. I think I have a video, if I'm not mistaken, that shows how this happens, or I could be thinking of a picture I used to use, but so this is a myelinated axon in the in relation to the Schwann cell, and this is in the PNS, and you can see it kind of just, it's like a jelly roll, right, or a pumpkin roll, right, the way it rolls around itself. Back to the slide, unmyelinated axons. Basically, the Schwann cells and oligodendrocytes are still there, but they're not wrapped around in the same fashion. And the axons actually kind of are nestled into what they refer to as invaginations of Schwann cells or the oligodendrocytes, and I'll show you that. So basically, the yellow would be the axons, and they're kind of just like pushed into the cells. So I usually refer to either myelinated or unmyelinated. It either has myelination or it doesn't. I know the book kind of says, well, there's kind of some myelination there, but it's a lot thinner. It's just easier to remember it as one is myelinated, one is not, and the one that is referred to as white matter. It's better insulated. It conducts way faster signals, and you're going to find gaps in between. In the unmyelinated, they're going to have a much slower conduction speed, and that's really, and it's referred to as gray matter, and that's really all you pretty much need to walk away from this with. So I'm going to stop here, and we'll pick up on the next part coming up.